This is 3.4 example in which a ball is thrown vertically upwards with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. This is given information. There are two sub-questions. A, how high will the ball rise? B, how long will it be before the ball hits the ground? Take acceleration due to gravity 10 meters per second square. In this example, you have a building. The height of the building is 25 meters, and from here you launch a ball. You throw a ball with the initial velocity. Initial velocity is 20 meters per second. The ball reaches height B, then again from this height it falls down. What is this height? Let me take from the total here to here, this height you can take it as y0, and this whole y is the total height. And I can say I'm interested here. From here, what is this height or the total height? Let me write it, y minus y0. The ball, you stand from the height of the building. The height of the building from the ground is 25 meters. From here, you throw a ball upward, and with initial velocity, it reaches a height B. This is A point from the top of the building. What is the height AB? I need to calculate y minus y0. With respect to earth, that is the ground, y is the total height. Let me start the first analysis, A1. It's a very simple analysis. What it gives you? First, initial velocity. Before that, the height of the building, which is 25 meters. Then we have initial velocity. As I said, initial velocity is 20 meters per second. And when the ball reaches it at the point of when you are about to throw, the initial velocity is 20. When it reaches the maximum height, it starts coming down. At the maximum height, final velocity is 0. So this is going to be final velocity. Let me write final velocity equal to 0. Now equation of motion, you have a simple formula. What is the relation connecting final velocity, initial velocity, and yes, y minus y0. So you have a simple analysis. Let me write it here. The whole simple analysis is looking into the given data. You have final velocity, initial velocity, height, and of course acceleration due to gravity. I need to take all this acceleration, which is equal to A equal to minus G, which is equal to minus 9.8 meter per second square everywhere. So when this is the case, A is also well defined, like A equal to minus 9.8 meter per second square. Now I'm going to write an equation of motion, the suitable equation of motion. Which equation of motion is going to help us? Yes. Now the question is final velocity square equal to initial velocity square plus 2 times A. It is actually y minus x naught, x minus x naught. So in this direction, y is taken positive. So all is y-axis, you can say. Anything from the earth upward is positive, anything from the downward is taken as negative. So this equation is replaced with, this is your equation of motion. I'll be applying this equation of motion. That is final velocity square equal to initial velocity square plus 2 times A means minus 9.8. X minus x naught is replaced with y minus y naught, because I need this distance A to B. From here, from this height, this already I know. What is this height? I am interested. When I put it, final velocity is 0 is equal to initial velocity is 20 square, and it is minus 19.6, and you have y minus y naught. When you simplify, you will be getting 400 minus 19.6. You have y minus y naught. Almost typically I can take it as a 20. I can take it as 400 minus 20. So it becomes y minus y naught. You cannot do it, then you have to divide it. Yes, then finally it becomes is equal to. Then finally I'm going to get this answer close to 20, which is written as 20 meter per second. It is 400 minus 19.6 y minus y naught. So this 400, it becomes simply 400 comes this side, or you take that side, it becomes plus side. So finally whole this becomes 400 by 20. 19.6 is taken as 19.6 is taken as 20. 400 by 20 is equivalent to y minus y naught, which is equal to this. In case you need a y is equal to 20 plus y naught, which is equal to 20 plus 25. The total is 45 meter. Means from this is A, this AC is 25 meter, up to here 25, here is a 20, means this is y minus y naught, I got 20 meters. So finally you can say this is 20 meter, this is 25 meter whole, y is equal to 45 meter. This is going to be, this relation is going to be just, this whole relation is going to be 20 meter. So you are going to launch a ball from A, it reaches a maximum height. At the maximum height, the velocity of the object is 0. So again, it is going to come down. The second part we are going to discuss. What is this height AB? AB comes out to be y minus y naught, which is equal to 20 meter. The equation of motion used is final velocity square, initial velocity square, plus 2 times A displacement, that is B minus A. Something like total length I have taken, it is y minus y naught. Finally, I will get 20. The whole height is 45 meter. The second part of the question is, as I said, the ball is thrown from A position, that is from the top of a building. The building is at a height of 25 meter. This is the initial position. When the ball is thrown with the initial velocity, V equal to 20 meter per second. The ball is thrown with the initial velocity from height of 25 meter. It reaches a maximum height and finally it is going to reach a ground. Final position, y equal to 0. Let me write. We need what is the total time taken through this whole path. It starts from A, it reaches some maximum height B, then it is going to like it goes and it comes down. So it starts from A, it reaches B, then it reaches a ground C. So from the height when I throw it, so it is given in this fashion. From the height of the floor, that is the building, the ball is thrown. Now what is the total time taken to travel A to B, B to C? So let me start the initial parameter. Initial position, it is at a height of 25 meter. What is the final position? It is going to reach a ground. With earth is taken as a reference marker. Final position 0. Initial velocity 20 meter per second. Yes. Then what is the acceleration? Acceleration is, you have an acceleration minus 10 or 9.8, you can take, both are valid here. Final velocity, of course we don't know with what velocity it's going to hit. I'm least bothered. Or you can take minus 9.8 meter per second square. Now which equation is going to help us? Equation of motion. To calculate time parameter, equation of motion, displacement equation. I had a final position, I had an initial position, I had a velocity, I had an acceleration. I need to calculate what is the time. So to calculate time, I will be using y minus y naught is equal to initial velocity into time plus half at square. This becomes y equal to y naught plus v0t plus half at square. Now all the values I will be putting into equation. This is 25 meter plus initial velocity 20. This I have a time as it is plus half as it is. Acceleration is minus 10 and a t square. Then of course y is final position is 0. Cross check. Finally, the object is going to reach the ground. Final position 0, initial position 25. 25, everything I substitute. Now this equation, this is 0. This is 0 equal to 25 plus 20t. This is becomes minus 5. Let me write. This equation simply becomes 0 equal to 25 plus 20t minus 5t square. So this can be rewritten as, from here this equation can be written, I can take it as 5t square minus 20t, 5t square minus 20t minus 25 equal to 0. So once I simplify this relation, this is 5t square minus 20 minus 25 equal to 0, same rearrangement. So it gives you very simple analysis. The value of t, if you simplify it, you can cross check. It is t square minus 4t minus 5 equal to 0. The quadratic equation, then t equal to 5 second. If you simplify it for t, like t square minus 4t, you divide it by 5, it becomes t square minus 4t minus 5 equal to 0.